Inga iwi, inga mana, inga hoa mahi, tēnā koutou katoa. Me karakia tātou. Ko te tae whakarunga, ko te tae whakararo, ko te tae tokoro, ko te tae tonga, ko te tae hauauru, ko te tae rāwhiti. Tēnei, ko te tae ohanga, homie, huie, taekie. E mihi ana ki a koutou, kua tae mai ki te tōkoko, tēnei kaupapa. Ngā mihi nui ki a Dirk Pilat, te kai kororo o te rā. Tēnā koe. No mai haere mai ki te tae ohanga. Aha koa no tā wāhi tūpuna I tūpuaki o I hakatere. Nō reira, ka te mihi aki ki te mana whenua. O reira, arā, ko kia te maunga, ko hakatere te awa, ko nai tāhu whānui te iwi. Ko Tim Hampton aho. Nō reira, tēnā koutou, tēnā tātou katoa. Ka huri ki te reo Pākehā. Kia ora, everybody. My name's Tim Hampton. I'm the Director of Economic System here at Treasury, and it's great to see everybody online, both here in New Zealand and those joining us from afar, particularly to you, Dirk. Thank you for joining us. We know it's getting quite late there in France. In terms of today's seminars, as you'll now be aware, this seminar is part of our current theme here at Treasury in terms of our guest lecture series around productivity in a changing world. To those of you less familiar with this Treasury series, we chose this theme as a focus for our guest lecture this year, as productivity is a known and key long driver of economic performance, wages, and overall living standards. And of late, New Zealand's performance in that regard hasn't been that great. The world around us is evolving quickly, presenting us with the challenge of lifting productivity among significant economic, social, and environmental shifts. Just like many other countries, New Zealand's navigating these challenges in a dynamic global context. That's why we're bringing together a diverse set of speakers to explore how these trends will impact New Zealand's economic performance and the ideas for policy in terms of what we can do. Please keep an eye out for the invites for the future lectures in this series. We've got a pretty good lineup coming up. In terms of today's presentation, we're really privileged to have Dirk Pilat with us. Until very recently, Dirk worked at the OECD as the Deputy Director of Science, Technology and Innovation. In this capacity, Dirk was responsible for managing OECD analysis and policy advice in areas such as innovation and technology policy, entrepreneurship, digital economy, productivity, global value chains, and green innovation. Currently, Dirk is a research fellow of the Productivity Institute, an associate researcher at the Valencia Institute of Economic Research, and a senior research fellow at the Lisbon Council. He's also currently a member of the UK Productivity Commission and was also a member of Ireland's National Competitiveness and Productivity Council. During today's session, Dirk will share his insights on the links between productivity, climate change, and innovation, with a focus on measurement methods. He'll also offer his reflections on future analysis and policy directions for addressing climate change and achieving net zero, while boosting productivity and encouraging innovation. Talking to Dirk a few weeks ago, I was particularly interested in the wide range of perspectives that Dirk's work covers, in contrast to some of the partial analysis that we often see in this space. Addressing these issues is obviously a huge topical issue for New Zealand and all countries around the world as we respond to the challenges of climate change and the transition to low emissions economy. You might be aware that the Treasury and the Ministry for the Environment here in New Zealand published the Climate, Economic and Fiscal Assessment earlier this year, which explored the economic and fiscal impacts of climate change within the New Zealand context. Analysis such as Dirk's is important to help decision makers in the public and private sectors identify and manage the risks and opportunities for climate change, including New Zealand's transition to a low emissions and climate resilient future. I'll now hand over to Dirk, who'll present for about 45 minutes. We'll then have the remainder of the time for questions and answers. I invite you to submit your questions through the Q&A function rather than the chat function, and then I'll facilitate that at the end. So thank you again, and over to you, Dirk.
Thank you very much, Tim, and it's a real pleasure to be with you this morning for you, this evening for me. And I'll ask Anna to start sharing the slides because I had some difficulties with it from here. But what I want to do is really talk a little bit about a fairly broad set of issues. I'm working on this paper looking at climate change and productivity, and it's really trying to bring together a fairly wide range of literature, and I wanted to try and dig in a little bit and look at the links between those issues. I've worked on productivity pretty much all of my career. I've worked on climate change a number of times at my time at the OECD, and I've also worked on innovation a little bit. And I think there are some interesting links here that I wanted to explore with this paper. It is work in progress, so I think your comments are still very much welcome. I hope to have a paper out sometime in the beginning of next year, but very much looking for comments. So if we go to the next slide, the key questions I will be focusing on are really what are some of the links between productivity and climate change, and mainly I will be focusing there on different measures of productivity that we might be looking at. I want to talk a little bit about what we know about the relationship, so really what's the evidence, what are some of the data that we have, not only at the moment, but also how we might expect productivity to evolve in the transition to net zero. Then I want to talk a little bit about sort of the compatibility of growth, of productivity growth, and climate change policies. There are some people who are talking about degrowth, that we can't have growth anymore. Can we have growth? Can we have green growth? Or do we need to look at something else? And what should we be looking there in terms of the indicators? And then finally, a little bit about policy, where I will also talk a little bit about innovation policy. So that's the questions. The next slide, Anna, is very much just the outline for you, which follows these questions. So basically, these are the blocks I'll briefly talk about. So let's go to the next slide, which is really just a transition slide to take us to the first set of issues, and immediately to the next one as well, please. So first, a little bit about concepts and measurement, and this is from the work that my former colleague Paul Schreier did at the OECD, looking at productivity measurement. It comes from the OECD's productivity manual that was published in 2001. And it basically is just looking at, well, what are the types of productivity measures that we typically look at? So typically, productivity is about relating a measure of output to one or more input measures. So we can look at, on the output side, we can look at gross output, or we can look at value added or GDP. And we can look at inputs like labor, capital, the combination of capital and labor, which then means that we are looking at total factor productivity or multi-factor productivity, and we can then incorporate other inputs as well. Now, what's special here is that I think there are some things that we may be looking at a little bit more than we typically do when we look at productivity. One is on the capital side, where I think it's very important that we include natural capital in the measurement of capital, not only fixed capital, not only intangible capital, but also look at natural capital. I'll say a little bit more about that later. Secondly, it's important to look also at things like energy, materials, and resources. So to specifically look at those inputs, which we typically don't do a lot as economists and people working on productivity, but it is important in this context because that's where a lot of the relationship with climate change comes from. And then, of course, also when we're looking at multi-factor productivity, to try and see whether we can incorporate some of these intermediate inputs in the discussion. So that's the first conceptual slide, just to say, well, we need to look at a broader set of productivity measures when we're talking about climate change. Let's go to the next slide. There's one other conceptual issue, of course, when we're talking about productivity and linked to climate change, which is that there are also, so if you can go to the next slide, Anna, is that we also, no, I think there's one before, sorry. And go back one. There seems to be one missing. Yeah, this is the one. So we also, of course, when we are dealing with the environment and climate change, that there are issues here that we typically have that raise some difficulties, because the bad outputs, sort of pollution, is not really measured by market prices, is not really taken into account in our measurement of GDP. So there are things that we need to do to really adjust our measures, our standard measures of productivity, for environmental externalities. And I will not go into all of these, but there are three that I'll say a few words about. One is basically just adjusting our measures of GDP for the fact that we may be producing bad outputs, we may be producing pollution. And if we do that, we adjust for that, then we basically will get a different measure of GDP, a different measure of productivity, where we adjust for those bad outputs. And I'll show and give an example of that a little bit later from some of the OECD work. The second set of adjustments that we may want to make, and I mentioned natural capital already, is to adjust our measures of capital for the use of natural capital. And there are two ways of doing that. Well, one is basically say, well, we have all these capital inputs, but we have all the natural capital. Why don't we actually take it into account in our measurement of capital more generally? Typically, we don't do that. We don't sort of take account of all the subsoil assets. For instance, we have all the minerals that we're extracting, the forestry resources that we're having. But if we do that, if we measure that as well, we take it into account and value it at market prices, at private cost, then we will have an additional source of capital input that is providing services to our economy and is adding to GDP. The problem with that one is that it is one way of doing it, but it doesn't really account for the fact that we may be perhaps also having other benefits of that natural capital: environmental benefits, health benefits, social benefits, other things that are important for us in terms of our well-being and our living standards. So there we might also want to go a little bit further and also start measuring that natural capital, not only at market prices, but also for the social cost, for the social value of that natural capital. And that is another way of starting to look at our productivity measurement. So just to say, from this first two slides is basically probably go to a number of other measures of productivity, and also look for productivity measures that adjust for some of these environmental externalities, because they will tell us more about the overall productivity story. So now let's go to the next set of slides, and we go to the next slide, Anna, and then the next one again, and go a little bit into some data and evidence. And here again, I think there is one before this. Correct. Yeah. So, and that's just a word about context, because I think, and Tim mentioned this already, of course, we are in most countries at the moment and globally dealing with the slowdown in productivity growth. This is a paper I just did with Bart van Ark and Klaas de Vries, where we were looking at G20 countries, and I'm just looking here at two graphs. One is basically for the advanced G20 economies, G7 plus Australia. The second one is a graph for G20 countries that are sort of countries that started from very low levels of income, but have had really high growth. So they are really much the catching up countries: China, India, Indonesia, Korea, and Turkey. And what you typically see here is that in both the leading countries, we've really seen a very much a slowdown in multi-factor productivity growth and TFP growth. So we would ideally like to see that, for instance, if we want to look at productivity, that if we are trying to go to net zero, that more and more of our growth doesn't come from inputs, from factor inputs, doesn't come from capital, from labor, but more and more would be coming from efficiency. And unfortunately, we do not see that in the advanced economies. We've seen a slowdown in TFP growth in many cases. And that TFP growth, if you look at the green parts, also for the lagging G20 countries, there also that part is now declining. There was a massive growth in that TFP growth for some time, but now it is really declining. So there as well, the slowdown is underway, unfortunately. Most of the growth is now coming from capital deepening. Some of that involves intangible assets, R&D, software, data, organizational capital, and particularly that is important in the advanced economies. But a lot of it is still also coming from machinery, equipment, and buildings. So We're not seeing what some people, and Danny Qua has called it, a weightless economy, where we would be seeing more and more of our growth coming from these intangibles. So let's now go to a number of other aspects of the productivity discussion on climate change. And we go to the next slide, please. And I first want to talk a little bit about the direct impacts of climate change on productivity. And I just have climate change on the top here, and then a number of possible ways that climate change might be affecting productivity. And these impacts may be coming through production. For instance, we could have an impact of climate change on agricultural yields, on tourism, on construction output. All these sectors may be affected. We may have impacts on capital. We may have more obsolescence of capital. If with climate change, we may see more destruction by natural disaster. We may have impacts on natural capital. We may have impacts on labor and human capital. For instance, if we have very high temperatures, it will be hard for people to work outside, so the intensity of work effort will be affected. We may have impacts on intermediate inputs, the cost of cooling, of insurance, for instance. We may have possibly impacts on innovation, and we may also have reallocation effects. So lots of impacts of climate change on different drivers of productivity that would then lead to sort of effects on agricultural productivity growth. And of course, there are lots of impacts as well beyond GDP, on health, on well-being, on living standards, and so on. I won't be saying as much about that today, but there are quite a lot of those issues as well. So what do we know about some of these things? If we go to the next slide, we do know a little bit about the overall macroeconomic impacts of climate change on productivity. There's been work on what's called integrated assessment modeling of the impacts of climate change on growth and productivity for almost 40 years. Some of that started in the early 80s already. And initially, a lot of that work basically suggested that the impacts of climate change on GDP would be relatively small. And that even with small degrees of warming, 1 degree of warming, the impacts might actually be positive. This is work by people like William Nordhaus, Richard Toll, and many others. The latest review of those studies, which was published by the IMF last year, still points to relatively small impacts, a median loss of only 3% of GDP by 2100, with degrees of warming between 3 and 4%. However, that IMF review also notes that a lot of these studies may substantially underestimate global cost by ignoring some of the worst case scenarios and not also accounting for the fact that, of course, the impacts of climate change will be very different between countries. So you might have African countries, small Pacific islands, lots of countries being very heavily affected, whereas Northern Europe perhaps might not be as much affected. So those studies that I mentioned, these modeling studies, these integrated assessment models, have been increasingly criticized, and I think particularly some nice papers by Nick Stern and Joost Stiglitz about this in the past few years, saying that a lot of the assumptions that these studies rely on can be questioned. There is particularly a problem that the risk of the climate passing certain what I call tipping points, I'll give a few examples of that in a second, may be ignored or underestimated, and we know that some of these are already close to being breached. The scientific consensus, I think, at the moment is also that climate change would have very devastating impacts on the economy and that large parts of the world would become uninhabitable. So I think overall there is growing evidence that perhaps mainstream economics has underestimated the impacts and cost of climate change so far, and that we've really have missed the boat a little bit on this in terms of the impacts that we are now seeing overall. So let me say a few more words about the criticisms that these studies have typically been confronted with in recent years. The next slide, please. So the main criticisms of these models are really about the fact that they have been underestimating risk. The big issue is also that we are typically discounting the future at a very high rate. If you have a very long period and you use a high discount rate, then of course the future doesn't account for much compared to today, which may have an impact, lead to relatively short-termism and underinvestment. I mentioned already the large differences between countries. A lot of criticisms as well by being too much focused on GDP and not on other key impacts like health. And also, I think from a productivity perspective, that sometimes the GDP growth rates that underlie these models have often been set in an exogenous way, which is also something that can be questioned. And then we have these tipping points, the fact that perhaps these models don't sufficiently consider the science of climate change, notably the risk of large-scale climate events, for instance, the fact that some of the ice sheets may be affected, the saturation of oceans as a carbon and a heat sink, and also in things like the Amazon forest being affected. So lots of criticisms on these studies, which means that perhaps we have been underestimating the impacts of climate change on growth and productivity over the past few years. So we'll come back to that a little bit later, but I do think this is something that I think from reading the literature at the moment, it seems to be something that seems to be coming forward quite clearly. So this is one source of information on looking at the impacts on productivity, but also I think it's important to look at some of these other indicators that I mentioned in the beginning. So if we go to the next slide, I want to talk a little bit more also about materials and resource productivity, and I'll talk about three types of indicators here. First is materials productivity. So it's basically just relating GDP to the amount of materials, the tons of materials that we're using in the economy. I want to talk a little bit about carbon productivity, carbon emissions productivity. This is one that's relatively well known, where we relate GDP to CO2 emissions. And I want to say a few words also about energy productivity, where we relate GDP to energy use. So the first one, and if we go to the next slide, is around materials. And typically as economists, we don't look at materials that much. It's an intermediate input. We don't look at it that much. But we do use an enormous amount of materials in the economy, and it's still going up also in OECD countries. The main ones are fossil fuels, obviously, metals, biomass, for instance, linked to agriculture, and also particularly a lot of non-metallic minerals, which is for construction. So sand, gravel, stone, other things that we are using. Now, the use of these materials affects climate change through the emissions that are coming from their use, linked to energy supply, particularly fossil fuels, of course, industrial production, think about cement, think about steel, and then also agriculture. But they also have other impacts, for instance, on biodiversity if we are using these materials. If we go to the next slide, we can see that the productivity of these materials, the use of these materials has been increasing. However, it's been increasing relatively slowly and also with large cross-country gaps between countries. So you can see the picture for New Zealand here. This is actually looking at what's called material footprint. So it's not only accounting for what you're using domestically, but also what you're importing as a country. So you see a slow growth in materials productivity, but it is a relatively slow growth, and we still see growing use of materials across the globe. So this is one indicator. Materials productivity is one thing we can look at. The next slide shows another indicator that I think is getting quite a lot of interest, is on carbon emissions productivity, where we are looking at the relationship between GDP and the production and consumption of CO2. We have two indicators here for CO2 emissions for different countries. Production-based CO2 is only looking at the CO2 that you're producing as a country within your borders, whereas consumption-based CO2 emissions also account for the fact that you're importing quite a bit of CO2 through, for instance, the materials and the products that you're buying from other countries. Now you see quite different pictures here for countries. In countries like the UK, Denmark, and France, we've seen a real decoupling between GDP and CO2 emissions. So we basically see that GDP is still going up, but in many cases, CO2 emissions are falling now in some of these countries. New Zealand has now stabilized more or less its CO2 emissions, while GDP is going up. So it's not yet in the situation of countries like Denmark or the UK. However, even in the UK, we are still dealing with relatively slow rates of decoupling. So if you're basically thinking about things like net zero, the UK at the moment on the production base produces about 120 grams of CO2 per dollar of GDP in 2021, and has had about 3% growth in carbon productivity over the past 30 years. But it would require a growth of about 8% of productivity in carbon emissions productivity to really reach net zero by 2050. So we're not really going fast enough yet in this sort of move towards carbon emissions productivity. If you go to the next slide, and I'll skip the next one actually, Anna, so we can skip this one. It's a bit more complicated, so let's skip this one. Go to the next one and talk about energy productivity. This is another indicator we can look at. One back, please. Where we also see a sort of increases in energy productivity, but again, with large cross-country gaps. There have been improvements here globally of about 1.3% a year, mainly due to improvements in energy efficiency, but also at the moment, electrification is becoming more and more important. So there are improvements here, and you can see also where New Zealand stands in this context. Now, energy productivity is quite important because it contributes very heavily to the improvements we're seeing in carbon emissions productivity. If we go to the next slide, where you can see that fairly clearly in the data, that growing energy productivity has contributed significantly to improvements in carbon emission productivity. What this slide does, it breaks down the growth in CO2 emissions productivity in two components, the growth of energy productivity and the decline in CO2 intensity. And what you see for New Zealand, that all of your improvements in carbon productivity have come from energy productivity, whereas we look at countries like Denmark or Italy, a lot of it has come also from a decline in CO2 intensity because these countries have moved to other sources of energy, renewables in particular, that have meant that they are now, that's where a lot of their improvement in carbon productivity has come from. So I've spoken about three indicators of productivity that I think are interesting to look at when we talk about climate change and productivity: resources, materials, carbon productivity, and also energy productivity. Let me end this more empirical part by talking a little bit about some three other indicators which I mentioned before, where we're trying to look also at the environmental externalities, and we're looking at natural capital. So if we go to the next slide, I'll have three more slides before we end this empirical bit, which is the first one is really about this adjustment for pollution abatement. I mentioned that already, where we are trying to sort of see if we are adjusting for air pollution and greenhouse gases, how that affects our measurement of productivity, where countries that have seen a decrease in pollution typically have higher growth, higher productivity growth when we adjust for these emissions, whereas countries that have sort of seen an increase in bad outputs tend to have a negative adjustment. So you see positive adjustments for quite a number of the European countries, and negative adjustment for quite a number of Asian countries, like also Turkey, India, and Korea. Now, the next one is a little bit about natural capital. I know this is an issue that New Zealand is already looking at quite a bit, where natural capital has made a positive contribution to GDP and productivity in several countries when valued at private costs. So if we just keep it into account in our measurement productivity, we get a positive story there for quite a number of countries that are resource intensive: Russia, Saudi Arabia, Chile, quite a number of other countries. However, this doesn't account really for the environmental and social value of such capital, because we're not really taking that into account. And there haven't really been many productivity studies doing that type of work, but I do think that is quite an important step to be making going forward. So let me end the more empirical part here and skip the next slide, Anna, and go to the next section, where I'll talk a little bit about policies from what we can expect for productivity when we're talking about policy. So if we go to the next slide, I'll start again with a slightly conceptual slide. What impacts could policies to address climate change have on productivity? And again, I've distinguished a couple of different impacts that come up in the literature. We could, for instance, of course, from climate change policies, we typically expect that if we are putting policies in place, that they may have costs associated with them. So we would have probably a negative impact from, for instance, the cost of taxation, of regulation on the cost of factor inputs, which would have a negative impact on factor productivity, which is the first column that you see. We typically also are looking at possible positive impact from innovation. This is what's called the Porter hypothesis from work by Michael Porter and Associates, which basically says that if we have well-designed environmental policies and regulations, we may be able to encourage firms to innovate, which could then help increase productivity. So there would be a positive impact of that one. And there could be other effects like impacts on international competitors. You may see shifts in reallocation of production. We may have comparative advantage in different areas. We may see impacts on resource allocation. We may see impacts due to changing demand. We don't quite know what the direction of these impacts is. And of course, again, we will have impacts beyond GDP that play a role here as well. So lots of different impacts that we might be seeing. So what do we know about some of these things? And let me go to the next slide. I think the first thing we do seem to know for quite a few countries that there is, of course, a lot of uncertainty about the future impact of productivity from climate change policies. And there are probably both positive and negative factors affecting growth. I think potentially positive is that the modeling estimates that we are seeing that of the costs of policy actions seem to be going down in many countries. And that's partly because of the rapid pace of technological change, the falling cost of renewables, which means that basically taking action, trying to reduce emissions is becoming perhaps cheaper than it was before. So what we currently see from also, for instance, the last OECD work I've seen on that is that the cost of policy action on GDP are relatively small compared to what they probably would have been some years ago. Also, there are quite a lot of sort of firm level studies now across quite a large number of countries, particularly OECD countries, that have tried to study what is the impact on firms of environmental and climate change policies. Most of those find evidence of stronger innovation, so they do confirm this Porter hypothesis, and they do suggest that basically that those stronger innovation impacts seem to compensate mostly for the cost of policy in terms of regulation or taxation and so on. So not a lot of evidence of really higher cost or really large cost of policy at the moment. However, this, of course, in many cases are relatively policies that have been implemented over a relatively long period, sometimes not very deep going. And I think, of course, when we're talking about policies that we might be expecting in the next few years, will have to play out over a shorter period, will be deeper, perhaps than a lot of the other previous environmental policies. So the cost might be higher. The other factors that could be leading to higher costs. So again, we're not entirely sure where this might be leading to, but there are some evidence, some pieces of evidence as well that there are maybe perhaps some benefits here as well that we might need to take into account. The OECD work, for instance, also says that there are relatively small cost of policy action on GDP. However, these studies don't really even incorporate the fact that by having these policy actions, we maybe also, so of course, no longer have as large damages of climate policies from climate change itself. If we go to the next slide, this is a little bit about labor productivity and multi-factor productivity and what we might be seeing there. Of course, I mentioned a little bit about materials and carbon productivity already, where the current pace of productivity growth in terms of resource use is too low. We will really need to accelerate quite a bit to achieve net zero goals. There is a discussion as well at the moment a little bit about what is happening with materials. Do we have the materials? Can we do all that mining? Where I think the evidence at the moment is saying, well, actually, we will need far fewer metals and far fewer materials for the transition to net zero than we're currently doing, because fossil fuels is a very sort of mining intensive process. Energy productivity, has thus far been quite an important source of improvements in carbon productivity. And there is still, I think the IEA sees particularly electrification and energy efficiency as very important sources of future growth in productivity. There is a possible risk of some rebound effects, which you typically get if efficiency improves, and probably demand might go up. However, the studies I've seen on that so far suggest that might be relatively limited. And then natural resources and productivity, something I think needs more attention. We're still depleting natural resources quite heavily, and we will probably need to invest more in this area. So a little bit about possibly the future. I think something more thinking is still needed in this area. I wanted to move on to a little bit about productivity, green growth, and degrowth. So let's go to the next block and talk a little bit about that issue. If we go to the next one, please, Anna. And that's a discussion that has been going on for some time. I was quite a bit involved at the OECD when the green growth strategy was developed, which was in 2011, where there was a stronger version which basically said that very much like the Porter hypothesis, that environmental policies can have a positive effect on growth and productivity even in the short term. A weaker version basically saying that, well, the cost might not be that high with some benefits. And I think that is relatively closely aligned with mainstream thinking, for instance, at the OECD. We have an alternative theory of some people at the moment that basically says, well, actually, we can't have growth anymore. We really need to abandon growth as a policy goal, reduce or close down polluting sectors and unnecessary production, reduce GDP, and really increase circularity in production. So this is the degrowth story where people basically are pushing for that. Now, I think, and if we go to the next one, there are many reasons why this is probably not a good idea. And I think talking partly to a Treasury audience, I think that will be familiar. If we go to the next one, please. A lot of criticisms, firstly, because most of the growth of emissions is not happening at the moment in a lot of the advanced economies. It's happening in emerging economies where poverty is still high. So having a focus on reducing GDP in advanced economies will not have a lot of impact on global emissions. We know, sorry, if you can go back one, reducing GDP, of course, has many other impacts. Basically, it would be a prolonged recession with high economic risks and cost. Reducing GDP is actually a very costly way of reducing emissions because we have good alternatives like renewables at the moment, which is a much cheaper way of doing it. It ignores a lot of the need for structural and technological change. It tends to focus very much on control, command and control mechanism with little role for markets. And then we're not even talking about the fact that these ideas might not be very easy to implement because they really involve thinking like we're in a zero-sum society. So I'm not a fan of degrowth, but we can talk about this and see what people think about that. I do think there are some problems with green growth. If we go to the next slide as well, I think the thinking that we're seeing is that the current rate of growth in carbon productivity, which is important in this context, is simply too low to achieve net zero. We're not there yet. We're not really seeing this combination of green growth, even though we see some of the coupling. The strong version of green growth actually has limited empirical support because we are probably not seeing that at all. However, we have a wide range of empirical studies that support a weaker version of green growth, where the positive impacts of policy on innovation seem to compensate for the cost linked to regulation and taxation. There are some people who go further, and the paper by Stern and Stiglitz is a very positive one, saying that green growth could contribute to a new growth narrative. They're really focusing on things like improved resource efficiency, increasing returns to scale, lots of factors that they're mentioning, saying, well, there could be a more positive story here than we're sometimes thinking about, and we need to drive this forward going forward. So my bottom line, and if we go to the next slide, is on this, is really that next slide, please. is that degrowth is not an efficient nor an effective way of addressing climate change. However, we will need to see a much more rapid move of improvements in carbon productivity to accelerate that, and also thinking that the exclusive focus of green growth on GDP and on productivity is probably no longer the right one. I mean, we were very much focused on GDP and saying we can have this combination of GDP growth, productivity growth, and climate change. And I think we need to look more at a lot of these complementary measures that I mentioned already, environmentally adjusted measures of productivity, the contribution of natural capital, living standards, and so on, to really move in that direction. So the main policy question, in my view, is how to rapidly achieve net zero while also supporting living standards and productivity. And I'll focus in my last part a little bit on drawing a few points out on that one. So if we go to the next slide, Anna, please, and the next one after that. Yeah, if we can go to the next one. No, I do think there is, quite a lot of clarity already about some of the elements of climate change policies. And I've just put a number of elements on the slide here, probably thinking about carbon prices, removal of fossil fuel subsidies to address environmental externalities, reducing policy uncertainty, innovation. I'll say more about that in a second. Policies to strengthen markets and demand for low carbon products and technologies like standardization, regulation, the role for public investment, the de-risking of private investment, facilitating resource allocation, the role of trade policies, and also, of course, a number of structural policies linked to skills and helping workers make the transition. So we know a lot about the types of policies that we probably need in this context and what the direction might be in many cases. I mainly want to say a few words about the role of innovation in this context. So if we go to the next one. From the work of the International Energy Agency, basically showing that climate neutrality really requires a massive system-wide technological shift. So what the IEA has done is basically looking at the different types of technologies that are needed to address the fact that activity may still be going up, but we need to get emissions down. What do we need for that? What are the types of technologies we need for that in terms of electric vehicles, hydrogen, wind and solar, and other types of technologies? And you basically see how that then adds up to a large reduction in emissions. If we go to the next one, the problem we have at the moment with the technology side of things is that some of these technologies are available, they are on the market, they are cheap in some cases. So the ones in green, solar PV, wind, electric cars, heat pumps, even some hydrogen-based technologies are available, are on the market. So what the IEA is basically saying, like, we are okay to reach our goals for 2030 with existing technologies. However, a lot of the technologies that we need to get to 2050 and to get to net zero are not there yet. So we still need to, a lot of these technologies are still in demonstration or prototype phase. So we will need to do more around these globally to develop these technologies and to bring costs down. And cost, I think, is the important part why innovation matters, not only in terms of the fact that technologies are available, but also because they become cheaper and cheaper, because that means that the economics of these technologies is starting to play a large role. So if we go to the next one, it shows basically how the prices, particularly of a lot of renewable energies, have come down enormously. Continuous innovation, that means that now solar technologies, wind technologies in many cases are very competitive with fossil fuels and have become the cheapest technologies. And the same is now happening with things like batteries and heat pumps, where technologies basically are really competitive, what is available in terms of fossil fuels. Now, this is important because I think this is a way to the innovation element is important because it helps us to also bring down the cost of policy action, as I mentioned earlier on. So if we go to the next slide, it is a slide from a paper from Darren Acemoglu and his co-authors some time ago, which basically looks at how the combination of carbon prices plus research subsidies or support for clean research really allows us to have much lower carbon prices and much lower cost of policy than we would have otherwise. So if you introduce research subsidies, support for innovation in the early years, it basically helps to make technologies competitive, and it will mean that you can have far lower carbon taxes that you would otherwise need to really drive climate change policies forward. I will skip the next slide. So if we skip the next slide, Anna, please, and then go to a little bit about what innovation policies I think are needed. I think globally we will need perhaps a little bit more of rebalancing of policies. A lot of the focus of innovation policies globally in most OECD countries has been on the fusion of existing technologies, not on development of these breakthrough technologies that we still need for 2050. So we will need to try and drive those technologies forward so we have them. We drive the cost of them down so they can become available for later on. I also think we need to look a little bit about the types of instruments that we're using there. The problem with innovation is basically it is more directed here. We cannot deal with general instruments. We really need to try and direct innovation in a certain direction so it helps us with climate change. Increase support for demonstration products, and also, of course, international collaboration and technology diffusion, especially to developing countries, because that's where the emissions really need to come down. Now, nationally, of course, for a country like New Zealand, a lot of the focus, I think, will need to be on absorbing and diffusing existing technologies, renewables coming from abroad, but also you will need to invest in your own innovation to really make sure it fits in your own context in terms of the types of things that you need to do in your own context, and you will have your own strengths and may be able to make your own contributions to frontier innovation as well that can help in terms of innovation. Let me skip the next slide as well, Anna, in the interest of time. I think I'm running out of time a little bit. I want to say my final slide on policy is a little bit about how we can perhaps have a combination of climate change policies that are also supportive of productivity. I think in typical, if you're looking at the types of policies that we need to deal with climate change, they will deviate from standard productivity policies, of course, because they are more directed. They're trying to focus on specific markets that are trying to be developed. So in theory, that would imply lower productivity growth. However, of course, climate change policies also will reduce the impacts of climate change on GDP and productivity. So I think we need to understand what is the default, what is the counterfactual that we're looking at. But I do think a good climate policy framework can reduce those potential trade-offs, reduce costs, and support productivity by making sure we have these price signals working, we have markets that are working, we are supporting private investment, or at least we're trying to de-risk it. We make sure that competition and market openness work. We are making sure we have stable and predictable policies. And also we allow for innovation policies that address some of those technology gaps and foster diffusion and the international collaboration element I mentioned already. So I think we can have this combination of climate change policies that are still also accounting for productivity and thinking about productivity, but it requires a little bit of thinking. So let me end with my conclusions, a couple of quick conclusions. The next slide, please, Anna, and then the next one, just to end with. My conclusions, and I'm still working on this paper. There's a lot of material here. I know that, and I'm trying to hopefully look forward to the discussion. First, my first conclusion is I think it is really important to broaden discussion on productivity and climate change. From reading the literature, it's a very fragmented literature, lots of people working from different areas that have worked on productivity. But I do think that people working on productivity need to think a little bit more on also about things like resource and materials productivity, the role of natural capital, measures adjusted for environmental externalities, and of course also looking at beyond GDP at well-being and living standards. And of course, that's something that I know you're doing quite a bit of already in New Zealand. I think the necessary measurements are increasingly available, but they need to be fully integrated in analysis and policy thinking. And I think that is something that needs to be taken forward. I think it's also important to clearly distinguish the impacts of climate change and the impacts of policy. I think the discussion is sometimes a little bit mixed up. I do think that mainstream studies have significantly underestimated the cost of climate change itself. There is a lot of uncertainty, quite a bit of uncertainty on the likely cost of policy action on growth and productivity, but there is some evidence that they may be relatively modest and declining as technological change reduces costs. So there is some hope there, particularly if you're also thinking about the fact that some of the estimates that we have there don't necessarily account for the fact that we are reducing the impacts of climate change. I mentioned already the current rate of carbon productivity growth and the rate of decoupling from GDP is far below from what is needed for net zero. There are some people who've said, well, we have this decoupling, it's all wonderful. The problem is it's not going fast enough. We need to really move much more quickly than we are at the moment. So accelerating productivity growth in this area is urgent. So to understand that better, what is needed there is important. I do think that degrowth is not an efficient or an effective way of achieving net zero. Rather, we need to design policies for net zero that to the best possible extent also support productivity growth. And I think policies for innovation are quite important in that context. And finally, and that's not something I spoke about, but it is interesting to see that actually, if you look at the economics literature, there are not that many economists that are really working on climate change. There are a lot of people perhaps in policy departments and environmental ministries and in economics ministries, but the economics profession, academics have not really worked that much on climate change. And Nick Stern and others have really looked at that recently, and it's unfortunate. And I think it's important also by working more with other disciplines on this issue, working more with some of the physical sciences as well. So let me end there. And if we go to the final slide, just to say the comments are very welcome. I mentioned already, this is still a work in progress. I'm working on a paper at the moment that I hopefully will be out sometime early next year. Comments are welcome. My Manchester email account isn't working at the moment, so please contact me at the Gmail address if you have any comments, and I look forward to your comments and the discussion. Thank you very much.
Thank you, Dirk, for that. Just a reminder to all the audience, if you've got any questions, put them in the Q&A function and I'll pick those up. As we sort of covered it in the beginning, it's covered a huge territory there, and lots of linkages for New Zealand. I think about our living standards framework here at Treasury and how do I order a lot of the stuff that you're talking about provides some more numerical and analytical approaches to help us and join up the different domains in LSF, living standards framework and within how do I order. So that's really good. It was great to see some of the it's good to see the global context that you outlined, and particularly for some of the big countries that are close to the technology frontier. But I also appreciated the references to New Zealand, and yet good to see adaptation drawn out. I think that's if I look across the research that I've seen anyway, I think that's an area ripe for future analysis. A lot of the work to date has been on the how to deliver mitigation most effectively, but as you note, the green growth isn't going fast enough to fully mitigate the effects of climate change, and therefore adaptation is going to have to be part of that. And how do we do that efficiently? And again, interesting, the chart, I think it was about slide 16. Growth in energy productivity versus the decline in CO2 intensity. Some of New Zealand's context is a bit different given we started with so much hydro electricity, but there's still definitely opportunities for energy switching across different industries as well. One chart that struck me, and I know it wasn't the main point of the topic, but was quite early on, the chart that you had that looked at the long-term contributions of labour productivity growth in the leading G7 and then the rest of the world. The thing that really struck me in that chart was basically there's been no TFP growth in leading G20 economies since the 1980s. And when I was looking through your policy prescription, which, rings true in terms of, good markets and, encouraging innovation and all of that sort of stuff. Yes, there's a bit of a resource allocation in that, but a lot of that's the sort of stuff that you would say is what you'd want for total, it would transmit through TFP growth. Given we've had none, according to those estimates, since the 1980s, despite moving to all of those policies being incorporated in a lot of those countries, what hope is there that TFP growth is going to be able to help us there?
That's a great question, and the paper I did with Bart and Klaas de Vries is partly about that. But I do think there is a need for policies, perhaps more, to think also about the innovation side of things. I mean, we have, if you're looking there's been a real freeze, I think, there hasn't been that much growth in total sort of investment in innovation actually globally as we might have liked. We've seen countries like China and India come online and contributing to investment in innovation, but we haven't perhaps seen as much. And there is evidence that perhaps it is harder to move the frontier as as before. So it's becoming more costly to really move innovation forward as it was before, and we haven't really kept up in terms of the investments that we're needing to make. Now, there is some hope that things like artificial intelligence may be helping us to accelerate innovation. And of course, I mean, it's not only about the frontier moving, but it's also about the diffusion of these technologies. And of course, that's where the OECD work has really been trying to focus on that in terms of, the diffusion, particularly from the frontier firms to sort of lagging firms. And I know also there's been a lot of work on New Zealand on that issue, I think, over the past few years. But yeah, I mean, the paper with the graph I showed is based on the conference board data, partly because it covers so many countries. It is a little bit different from what we're seeing in, for instance, the OECD data or in some other databases, partly because it does a little bit more about adjusting deflators for information technology, which is something that we can discuss. So you would get a slightly different picture with some other databases, but I do think you typically do see in most cases that, we don't see as much TFP growth as we would like, and that's disappointing. Now TFP is a residual, so there are many things that may be happening here. We may not see some of the spillovers that we would be expecting. We may not have the spillovers from investment in ICT picking so far. There may be still some missing things. Some people like Eric Brynjolfsson are saying, well, yes, they're just around the corner. They're just coming. It just needs to feed through the system, and we'll finally see some of these impacts as well. But I think we are at the moment stuck with the fact that we don't have a lot of TFP growth, and that is also, I think, in the link to climate change, something that is disappointing and something that we need to probably have more effective policies for. So it is not something that I have any quick answers for, but I do think it is a real concern at the moment.
Yeah. Thanks for that. I think it is really useful to have that distinction again you had in the presentation, and just then about the distinction between frontier technology and diffusion. And again, thinking about that in the New Zealand context, particularly in the agriculture space, both because that's where our research tends to be dominated, but also because it is such a large share of our emissions. That's probably is an area where we're in many cases we are the frontier, but given our overall productivity performance and how far we are behind the global frontier, I think policies focused on the diffusion of other technologies, I think, is important. Got a question that's come through in the chat, and just ask everyone to put their other questions in the Q&A section. What's your view on the extent to which carbon pricing will actually induce innovation, thereby reducing the need for directed policy support? So rather than just resource allocation, the extent to which it actually triggers the innovation.
Yeah. No, I think it does. I mean, there is a nice study which was done by the CPB in the Netherlands recently for a very large firm level study. They looked at climate change policies across a large number of OECD countries with firm-level data for about 3 million firms. And they find that the SD climate change policies are inducing innovation. So I do think carbon pricing does play a role. I think the problem is a little bit, you need very high carbon prices to really induce innovation in certain areas. I mean, for instance, think about, you can have a, say, carbon tax of $30 to $50 per ton, but that won't really perhaps make much of a difference if you have a steel sector, for instance, where you really need to move to a completely different technology with very high costs. So I think you need to have this combination, and that's, I think, the insight of the work from Darren Acemoglu and others, really to say, well, you need to have this combination of support for innovation and carbon pricing to really induce innovation across the board and really deal also with the more difficult cases, to induce it at areas where perhaps the cost difference between a clean technology and an existing technology isn't very high. There it will probably do a lot of the trick, but if you really need to move to more difficult areas, more costly areas, you will need also, I think, this support, this long-term support for innovation to really move things forward.
Nice. Got a question here, sort of linking into the measurement side of things. Where renewables are more efficient, could the short-term result look like degrowth using existing measures of, GDP, etc.?
Not sure if I understand that question entirely. I mean, in what sense? I mean, can you rephrase it once more, or can you ask it once more?
Dean, are you happy to just turn your microphone on and just provide a bit more context, please, Dirk, for Dirk, Dean? Might come back to that. So, Dean, if you
yeah. I mean, perhaps what I can say. I mean, I would say that, to me, that there will be sectors of the economy that probably need to shrink. And if you're thinking about sort of climate change, I mean, hopefully, there will be some sectors that will be transformed because of new technologies that are coming in that allow for cleaner options. There will be some sectors that will probably grow, some firms that will grow because of demand, and there will be some sectors that will probably decline. I mean, some of the fossil fuel sectors may be sort of may be able to transform fully or entirely or to some extent, but some sectors will probably decline, others will grow in size. So what the overall effect of that will be, I don't know. I think we will see probably a lot of structural change in our economies at the firm level and to some extent at the sectoral level, and whether that will be degrowth or not. I mean, some people basically say, well, we're just too much focused still on GDP. And I think there is some truth in that. I think, if you're also thinking about the fact that you're addressing climate change, you're reducing pollution, so the gap between your environmentally adjusted measure of productivity and your standard measure of productivity will be growing as well if you're doing quite a lot to reduce emissions and to really improve your environment. So we will probably need to focus a little bit less on GDP and also on some of these other measures to really track on what is going on and try to focus on what we really need to move forward on. And GDP, I think, will become less important in that context. So that fits, I think, also a little bit with your living standards framework, of course, at Treasury, in the sense that you're already looking at a wider set of indicators, which I think is particularly important in this context.
Yeah. No, I think that Dean just provided some extra context, but I think that gets into it. Again, on the product, on the measurement side of things, you've talked about incorporating the climate change externalities or the externalities from climate change into your measures of productivity. There's obviously a whole lot of other societal, etc., externalities. Have you seen many attempts at trying to do climate change and other externalities? Because the risk being, if you just focus on the climate change externalities, then again, that creates a different kind of distortion.
Yeah, no, I think there is a little bit of discussion. I mean, at the moment, my feeling is this is a very fragmented literature. There's lots of different pieces. There people looking very much at resource productivity, people very much looking at energy, the people looking very much at more specific elements of the discussion. There are people looking more at well-being. There are people looking more at sort of there's a discussion and a slide I skipped in interest of time, which is work that people are doing on the United Nations Environment Program came with that on thinking about inclusive wealth, where we're basically looking at human capital, at produced capital, and natural capital as sources of growth and what that is doing. So I think it is still a bit of a fragmented discussion with bits and pieces, and I want to try and bring some of these things together, but that may be too ambitious because there are too many things going on here. But yeah, there are some people I think looking more as well on some of these other issues, the social side of things. There is a lot of discussion, of course, also from the more technical work of the IPCC, looking beyond the economic impacts, looking at other impacts. So those elements, they are there, I think. To what extent they all fit into a productivity story is something I think I still probably need to think a little bit more about, and to some extent, well, how clean, how many things can you bring under one heading of thinking about productivity? Because you're very quickly going in things like living standards and well-being, and that takes me then a little bit too far, probably from what I'm trying to do in this paper. But yeah, they're important issues to look at.
I've got a question, another sort of measurement-related question, productivity that sort of narrows it back down again to the impacts of climate change. So, how do the findings on productivity and the use of resources relate to the New Zealand economy, which is more heavily weighted to primary production rather than manufacturing? Does energy productivity also include productivity in the use of inputs to primary production, e.g. grass, that ultimately lead to methane rather than CO2?
I don't think it does. I mean, one thing I haven't done with this paper yet is at the moment I only showed CO2 emissions relative to GDP. My former colleagues at the OECD actually today released their new ICIO TIVA data, which basically has also, and one of the new things, which is basically a global input-output framework, where they're also doing a lot of work on CO2 and greenhouse gas emissions, and now they have widened that work to include a much wider set of greenhouse gases. So I'm not sure if methane is in it, but I hope it is in it, because that I think will tell us more about that picture. I don't think methane would be included in energy, because basically it is very much looking typically at primary energy in terms of energy going into the sort of the energy supply system or into firms and so on. So it wouldn't be looking at sort of the primary energy in terms of grass. I'm a farmer's son, so I know what you're talking about. But I don't think that would be looking at it. But yeah, methane. Of course, New Zealand, like the Netherlands, like Ireland, has problems with that, because agriculture is a tricky sector in this context, in the context of climate change, to think about.
Moving back to the point about pricing carbon, etc. And I noted your slide earlier that said, if you invest in the innovation, you might need as strong a price signal, but you're saying that there does need to be a pretty strong price signal to trigger both the resource shift and the innovation. The politics, it seems pretty challenging. The price signals seem politically unpalatable, making it hard for the signals to survive the political process. Do you agree that that's a challenge, and do you have any suggestions on how to resolve that tension?
Yeah, no, I do think it's a challenge in many countries. It's perhaps less of a challenge in some. I think Europe, I think, has benefited from the fact of having a mechanism in place for some time. But also, if I look at the Netherlands, there's been a slow increase in carbon pricing. Also, more industries, more sectors being brought under carbon pricing regimes. But yeah, we do know that in many countries this is difficult. I mean, I think the OECD, when I was there was always, asking the US, why don't you use carbon pricing? And in the end, they went with IRA, which is basically a very different way of doing it, but it is, I think, also can be a way of pushing forward on climate change, but without sort of the benefit from having clear price signals. So ideally, I think economists will always say we need to have to deal with these two externalities. One is this sort of the environmental externality, which is sort of what we need carbon pricing for, and we need to deal with the more sort of knowledge externality, which we need innovation policies for. So I think you need to deal with both of these, but in some countries it is very difficult to deal with the first one, with the carbon pricing issue. Higher prices, I think, of energy in some countries have helped, probably in recent years at least have held. But yeah, it is hard to sell, and unless I think you do a lot around sort of the compensatory policies that basically sort of try to also particularly help sort of lower income households to adjust to the fact that prices and costs are going up, which is not an easy task either. So yeah, it is, I think, a difficult one to deal with, and so I don't think there is necessarily one way of doing this across countries. I think countries have to figure out what will work in their own context. And the interesting thing is that I think why I mentioned a little bit more about innovation policies is that they tend to be policies that are more easily accepted as well. I mean, they tend to be policies that people don't seem to object to too much. And I think they have the benefit of bringing costs down, which will then make it easier to perhaps implement some of these technologies. I think the issue of making policies palatable in this area is important. Why I think also why it is important that things like having heat pumps, for instance, is the type of technology that can really show people that renewables or at least cleaner technologies can actually be beneficial, or at least reduce their cost in the long run. So, you know, there are things that I think can show to people as well that moving towards cleaner technologies doesn't need to be a costly thing, but can be something that's quite beneficial, even for their own pockets.
Yeah. And yeah, I'd agree in terms of having, settings that are relevant for each individual country. At the same time, I've tended to find it easier to get policies through when you can point to it having already been done in another country, particularly where that is a country that's competing in the same markets, etc. That's a big challenge for us in agriculture, because other countries' agriculture is not such a big part of their emissions, but is politically a big part. There's no policy done in that space. So, in your presentation, you sort of downplayed or both the need or the effectiveness of degrowth in getting towards net zero. Question in here about some other planetary boundaries. So even if we found an unlimited source of clean energy and reached net zero, there are still pressures on water, biodiversity, soil, population. How can we really resolve these wider problems while thinking about climate change task?
Yeah. I agree, and I fully agree. There are these planetary boundaries, and I think economists need to be more conscious of those. From all the things I've read about degrowth, the economic arguments are just not very convincing. I think I do think we need to look more at how we can live in those boundaries. So I think that's also why I think it is important to focus more on things like resource productivity, materials productivity, these types of measures of productivity, try and see, to understand a little bit what can be done there. And some of those areas may not have very large impacts. I mean, but there are other areas where impacts on biodiversity, on the water, as your question was, are definitely increasing very much. So I think there are things to look at there, and then we need to be more conscious of those and definitely work on that. I just don't find the arguments that are coming from the people focusing on degrowth are particularly convincing or helpful or really relevant to the debate on climate change. But I do think it's something that seems to be getting traction, at least in some areas, and I just don't think the economic arguments are there. I do think we need to look at the scientific arguments, which is also why I ended my presentation saying, like, we need to have more collaboration between economists and sort of people working on natural sciences and other areas, because I think that connection needs to be made more here, as it perhaps has been in some cases. So I think that is important to bring those discussions together. And I'm happy to have more of a discussion with people working on degrowth. I want to know more about it, which is one of the reasons why I put it in the paper, because I think it's important to have that discussion and to bring these issues to the table and to the discussion.
And it certainly has generated interest in the questions coming through. So one here that I think sort of reinforces and makes exactly the point you're making is, I was wondering if degrowth and green growth is really mutually exclusive. Could we not encourage growth in sustainable sectors over production, consumption, and less sustainable ones?
Yeah. No, there is something in between. There is actually something called EA growth, which is basically a Dutch economist who works in Spain, Jeroen van den Berg, who also works at Amsterdam, and he basically said, well, let's not focus too much on growth anymore. There are areas where we will need growth. There are areas where we don't need growth. Let's focus on some of these other indicators. Let's focus more on living standards. Let's focus more on some of these other measures, and bring the story together. I mean, I was involved at the OECD on the development of the green growth narrative at times, and I don't think that is quite there yet either. Even though I think there are perhaps some positive signs, as I mentioned, but I do think we're not there either on that. So I think we need to sort of see a little bit where that overall narrative is, and what the way forward on that is, and that may be somewhere in between all of these in terms of the overall story. And I think that's the issue of where the point of planetary boundaries is definitely an important one.
When you talked about in the enablers for innovation, both at the frontier, but particularly in terms of diffusion, you mentioned in passing competition and openness. Do you think the trend towards autarky is going to be a major or a minor barrier to net zero transition?
That's a good question. When I left the OECD last year, there was definitely something a lot of my colleagues were starting to work on more. I think we do know that perhaps focusing more on autarky is not a good thing. At least we do depend, I think, on in many cases on the exchange of products, of goods and services, of knowledge, and so on, and we benefit from that, and I think we have a lot of evidence on that. But I think security discussions, of course, play a role here as well in certain countries. Even though, if you're looking in the devil of the detail in terms of really developing autarky, is not such a realistic thing in quite a few of the sectors I think that we're talking about here. However, I think there is a discussion, in the European case, is that, less dependency on Russia in this case, less dependency in some cases also on China, particularly in terms of some of the key inputs in renewable energy and so on. So that discussion is definitely there, but I think it is a concern probably in the overall global sort of policies for climate change, because I think we do need a lot of collaboration. I mean, this is not going to work overall if we only have a number of advanced OECD economies making progress. We need the whole world to make progress, and particularly countries like China and India, but also a country like Russia or others that need to play their part in all of this. So yes, you need to have that collaboration, and so full autarky, I think, is not necessarily a very good thing in this discussion, I think.
Nice. We've got one question in here. Is it feasible to apply some of these environmental productivity measures to individual firms when making public investment or other policy decisions? So I'm just trying to work out whether measures means measurement, or whether it means initiatives.
Well, I think at the firm level, of course, I mean, if you're talking about policy measures, then they are typically more at a higher level than firms, even though individual firms may benefit from them. I think, I mentioned earlier on productivity, innovation policy measures. I mean, you may be providing sort of competitive grants to certain firms that are particularly strong in a certain area, and you may be awarding supports for certain firms. That of course. Other policy measures will be more across the board and will be affecting more generally firms. In terms of the measurement, if that's the question, I think, of course, some of these things you can probably measure in relatively great detail, even for individual firms. I mean, you can probably look at their, energy use. You can look at their material use. You can look at some of these things also with possibly with firm level data, if that exists for certain firms and exists with. And other cases, if you're thinking about, social sort of productivity measures adjusted for environmental externalities, then you probably will want to do that at a slightly higher level of aggregation to look at the industries or sectors or something like that, or the aggregate. So there are different things. I mean, I always believe that it's very important to bring different studies and levels of studies. I've enjoyed working in the past few years a lot with micro level data. My team was doing a lot of work on that. I think that's really important. But you also, I think, need aggregate studies. You also need sectoral studies, and you also need sort of studies that bring things together across countries. So you need to have that combination of levels of aggregation, of levels of study, I think, to really understand what is happening, and then the different measures of productivity that need to be looked at. So I hope that responds a bit to the question, but it wasn't entirely clear, but I hope that responds a little bit.
You covered both elements. Well, thank you very much, Dirk. I'm conscious it's now 10:20 at night, your time. As expected, it was a very broad speech, going in depth, triggering quite a lot of interest. I encourage those online to we'll share the slides shortly with everyone. But Dirk, as he said, this is a work in progress, and he's keen to get any engagement and reflection. So those that do have the time and the interest to engage with Dirk, he'd really appreciate that. So thank you to Dirk. Thank you to everybody online. Our next Treasury guest lecture is actually next Wednesday, with Professor Kevin Fox from University of New South Wales. I personally, many years ago, learnt a lot from Kevin in terms of their different approaches to measurements for different indices, with holding volumes and volumes or price, which at the time seemed quite theoretical, but over time I've realised it was actually quite an important lesson. So I've got a lot of respect for Kevin. So this will be a hybrid event. So anyone in Wellington's welcome to join us here at one of the terraces. So check on the Treasury website for the registration details. And so there's just a question there about the slides. The slides will be shared with anyone who registered for today's talk from Dirk. So let me now close our seminar with a farewell and a whakatauki, which says that discussion, learning, understanding and knowledge underpin the well-being of all people. Mā te kororo ka mōhio, mā te mōhio ka marama, mā te marama ka mātou, mā te mātou ka ora te iwi, homie, huie, taiki. Thank you once again to Dirk and to everybody participating online. Take care.
It was a pleasure. Bye.